Hey guys, welcome to 8.4, day 2. We've been discussing the bell curve and also standard deviation. As you recall, standard deviation is the measure of how spread out the data, and there are 2 or 3 standard deviations. Here is the one standard deviation from the mean, if that's the mean. Here's 2 deviations from the mean, and here's 3 deviations from the mean. All right, let's make this one really quick and short. Number 1, Danette and so-and-so work on a computer repair factory or company. They must include the time it takes to complete each repair and log their work. Here's a dot plot, okay? Some information here and here. As you can look at this data is more compressed, more compact. This is definitely spread out. So my guess is that this is going to give us a lower standard deviation, or we call it sigma, and this is going to be a more spread out. Predict whether Danette or Alfonso have the greater standard deviation in the repair times. Explain your reasoning. Okay, so I think I discussed that. There's going to be a smaller standard deviation, and this is going to be wider. Look at the numbers are spread out. Letter B, determine the standard deviation and round your answers to the nearest tenth. So in your calculator, go ahead and if you don't have a calculator, make sure to go online and type this in your Google search, okay? If you don't have the app that gives you the standard deviation, you can go online and use calculators. Type how to get standard deviation online or something like that. Or you could type statistics calculator online free, something of that nature. And you're going to be entering in the data, okay? There'll be one, so the data you're going to be entering, for example, on the net is 1, 1, 1, 1. There's 4 ones, so you got to type them separately. And there's 2 2s, and there's a 3, and a 7, and 2 8s, and then 2 9s. So this is the data you're going to be typing in for Danette to figure out your standard deviation, okay, your sigma. Go ahead and do those. All right, let's do a review, and then you can do this later on your own. Letter E, the owner repair has some stern bonuses for employees. Okay, should the owner look at the mean, the median, or the standard deviation when determining who gets the bonus? All right, this is something you should discover. So the owner wants to give bonuses, but he doesn't know whether he should base it on the mean, the median, or standard deviation, okay? So that'd be something for you to think about, okay? You want to know, do you want to give them for the people with the highest average, or the middle number, or whoever has the most compact, who's most consistent, okay, in their repair hours. All right, next one. Alfonso explains to bosses that the average repair time does not actually reflect how fast he is because he had a very difficult repair that took over 10 hours. All right, so this one took 11 hours, but boss, you can't really count me because this one took a long time. So you, as a statistics person, can figure out a way to remove that statistical anomaly and focus on this. Does the standard deviation take that into effect? Okay. All right, look at the next page. All right, next page. G, calculate and compare the mean and standard deviation of Alfonso. Okay, so you got to do that one, took. And do it without the 10 hours, okay? With and without, so do both and see if it makes a difference. So compare the one with and the one without, okay? Is Alfonso correct in his explanation of bosses? Does it really reflect a difference? Okay, so you want to discuss that. Letter number 3, calculate the mean and standard deviation for each data set without calculator. Oh, snap, no calculator. All right, so for number 3, you will not get any points if you do not show your work. So first, we need to find the mean, okay? So add all this up and divide it by how many there are. That'll find your mean. Okay. So I need to show all the work. Okay. Even if you can't use a calculator, you have to do it all by hand. Next, find the variance. Okay. Find the distance. The distance of each point to the average. Okay. I don't know what the average is. I don't want to give it away. You just have to figure it out. But for example, let's pretend the average was 15, just say. Okay. Just pretend it's 15. So say, hey, how far is 1 from 15? Well, that would be 14. And then each of those, you need to square it. Okay. And square each number. Then add them up. Add them up. Then divide by how many, divide by how many there are, right? The number by n. Okay? And divide by n. And after that, you get the square root of the whole thing. Then root it. So basically, it's that formula, that guy right there. Okay? That's the formula right there. Okay? Just a review. Find the mean. Then figure out the difference between each point. Then add up all the points, all the differences, divided by n, it's n, and then get the square root of it. Okay? Use the work. Make sure there's a lot of work. All right, next, number 6, the data represented by the dot plot. Okay, same thing, okay? Same as number 5, okay? All right, next page. This one you could actually use your calculator, so this should be quick, okay? Figure out the mean and the standard deviation, okay? Same for that bad boy. Make a prediction. Same for this one. Okay. And number 13, analyze the data sets below. Describe the distribution. Okay, now you use some words. Describe it. Are they compact? Are they spread out? What do you think? In comparison from A to B. Predict which data has a higher standard deviation. Explain your reasoning. All right, guys, it looks like we didn't have anything of what we did on the spread. So as an added bonus, I would like you to do this, and I'll give you an extra 10 points. So the bell curve, okay, of this data. All right, let's pick some numbers. Let's say we have 23, 35, 42, 51, 60, 69, and 120. Let's see, let's make it 95. Okay, that's 95. Okay. All right, so I would like you to do this for this one right here. You can do it on the back. I would like you to do the bell curve. So you need to find your mean, and then you need to find out the values of your oops. Okay, so this should be dashed. Okay, and this is one deviation, so I need the values that will go here. That would be your mean. And then one deviation away from the mean, and then another deviation away from the mean. And then I want to know 2 deviations away from me. I'm going to call 2D for deviations. 1 deviation, 1 deviation, 2 deviations. And it'd be kind of cool if you shaded them a little bit. And then lastly, I would like the 3rd deviation. And what is that value? So what I want to see here is a number here, which is your mean, and then one deviation away from that number here, and then the deviation over here, how much is it? So it'd be the plus, so this would be plus, right? And this minus. And then 2 deviations away from that, which will be here. What number will that be? And then what number will that be? And lastly, the 2 numbers for the third deviation, which would be 3 deviations away from the mean. All right, guys, great job. I'm really proud of you guys. I really want you guys to do well. I care about your education. Ask lots of questions. Post your stuff on the Schoology. And ask questions on Schoology. Others will reply. Okay? Have fun. Bye-bye.